In today's video, we are going to learn integration of tan of ax plus b with respect to x, integration of cot of ax plus b with respect to x, integration of sec of ax plus b with respect to x, and integration of cosec of ax plus b with respect to x. So let us start with integration of tan of ax plus b with respect to x. Whenever integration of tan x is given to us, there can be two situations. First, integration of tan ax with respect to x, and the second one, tan of ax plus b with respect to x. In both the situation, the procedure is remaining same. First of all, let us learn how to do integration of tan ax with respect to x. Call it I. Then step 1, let ax equals to t. Now differentiating with respect to x, differentiation of ax with respect to x equals to dt by dx. Therefore, a equals to dt by dx implies dx equals to dt upon a. Therefore, I equals to integration tan, in place of ax I can write t, and in place of dx we can write dt upon a equals to 1 upon a common, integration of tan t with respect to t equals to 1 upon a, integration of tan t nothing but log sec t, log of modulus sec t plus c. Now putting back the value of t, so we get 1 upon a log sec, in place of t write back the value t equals to ax, so write down ax here plus c. So this way you can do integration of tan of ax with respect to x. Suppose tan of ax plus b with respect to x given, how to do? For that, let us call it I equals to, then the procedure remaining same, let ax plus b equals to t, then differentiating with respect to x, the procedure is remaining same. So differentiation of ax plus b with respect to x equals to dt by dx, differentiation of ax is a and differentiation of b is 0, a equals to dt by dx implies dx equals to dt upon a. Now therefore I equals to integration tan, now ax plus b is replaced by t and dx is replaced by dt upon a. Therefore I equals to 1 upon a is taken outside as a common, so integration of tan t with respect to t, that is equals to 1 upon a, and integration of tan t, that is integration tan t with respect to e, 1 upon a, integration of tan t nothing but log modulus sec t plus c, this is 1 upon a log modulus sec, what was the t? T nothing but ax plus b, so writing down here ax plus b, modulus is closed, plus c. This way the integration of tan of x plus b with respect to x equals to 1 upon a log of sec of ax plus b written in the modulus. So this way we can do integration of tan x with respect to x. Let's take one example. Suppose we wish to find integration of tan 5x with respect to x. Then let 5x equals to t, then differentiation of 5x with respect to x equals to dt by dx. The given question is not in standard form. To convert into standard form, we need to make the substitution. So substitution method, so it can also be called as a substitution method. So derivative of 5x is 5 equals to dt by dx, implies dx equals to dt upon 5. And suppose uh, this is I equals to. Now what I can do, I equals to here the phi x is replaced by t, so integration of tan t, and the dx is replaced by dt upon 5, and 1 upon 5 is taken outside, integration of tan t with respect to t, so this is equals to 1 upon 5, and integration of tan t nothing but log of modulus sec t plus c. Now replacing back the value of t, that is a t nothing but 5x plus c. Therefore integration of tan phi x with respect to x equals to 1 upon 5 log of modulus sec 5x plus c is required solution. Suppose we need to find the integration of tan of 7x plus 8 with respect to x. Then the procedure remaining same. Step number 1, let 7x plus 8 equals to u. You can select any here. I wanted selected another one. You can select t, u, v, z, anything. So whenever such selection is done, we have to do derivative. So differentiation of 7x plus 8 with respect to x equals to du by dx. So 7 equals to du by dx. Therefore dx equals to du upon 7. Therefore given question becomes I equals to integration of tan 7x plus 8 replaced by u, and dx is replaced by du upon 7. After that I equals to 1 upon 7 taken outside of integration, it is a constant, tan u with respect to u, so 1 upon 7 integration of tan u nothing but log of sec u plus c, 1 upon 7 log modulus sec u. What is the u value? 7x plus 8 plus c. So therefore integration of tan of 7x plus 8 with respect to x equals to 1 upon 7 log of modulus sec of 7x plus 8 plus c. Now example 2, how to do integration of cot of ax plus b with respect to x. Now integration of cot x with respect to x, the basic formula is integration of cot x with respect to x equals to log modulus sin x plus c. Now there are the two situations, integration of cot ax with respect to x, and the second situation integration of cot of ax plus b with respect to x. Here in cot ax, so let ax equals to t, differentiation of ax, whenever you put equals to t you have to do derivative, so differentiation of ax equals to dt by dx, derivative of ax is a equals to dt by dx, implies dx equals to dt upon a. Therefore I equals to, I is nothing but given question, I equals to integration of cot, in place of x write down t, and in place of dx, here is the dx, in place of dx write down dt upon a. Now a is a constant, so 1 upon a is taken outside, so 1 upon a integration cot t with respect to t, 1 upon a integration of cot t nothing but log of sin t plus c. Now put the value of t back, t nothing but ax, so 1 upon a log modulus sin of ax plus c. This is required solution. And now suppose we are given cot of ax plus b with respect to x, then let ax plus b equals to, you can select any other letter. In the left side I have selected t, but you can select any other letter, like let me select u. So ax plus b equals to u. Now as soon as you select some substitution, you have to do derivative. So differentiation of ax plus b with respect to x equals to du by dx. Derivative of ax is a and derivative of b 0 equals to du by dx. Therefore dx equals to du upon a, implies I equals to, therefore I equals to integration of cot. In place of x plus b, write down u, and in place of dx you can write down du upon a. Now 1 upon a taken common. Integration of cot u with respect to u equals to 1 upon a, and integration of cot is nothing but log modulus sin u plus c. So that is equals to 1 upon a log, what is u value? That is u equals to ax plus b. So sin of ax plus b, modulus is closed, plus c is required solution. For example, suppose we need to find integration of cot phi x with respect to x. Then how to do it? So step 1, let phi x equals to u, then derivative of phi x with respect to x equals to du by dx. Derivative of phi x is 5 equals to du by dx. Therefore dx equivalent to du upon 5. Therefore integration I equals to cot, in place of phi x write down u, and in place of dx write down du upon 5. That is phi x equals to u and dx equals to du upon 5. Now 1 upon 5 taken common. Integration of cot u with respect to u equals to 1 upon 5. Integration of cot u nothing but log modulus sin u plus c. 1 upon 5 log modulus sin u nothing but 5x plus c. Therefore integration of cot phi x with respect to x equals to 1 upon 5 log of modulus sin 5x plus c is required solution. Suppose we need to find integration of cot of 11x plus 4 with respect to x. The procedure remaining same. Let 11x plus 4 equals to u. As soon as you put substitution, you have to do derivative. So differentiation of 11x plus 4 with respect to x equals to du by dx. Derivative of 11x 11 and derivative of 4 is 0 equals to du by dx. Therefore dx equivalent to du upon 11. Therefore I equals to integration of cot, in place of 11x plus 4 write down u, and in place of dx write down du upon 11. 1 upon 11 taken common. Integration of cot u with respect to u. After that I equals to 1 upon 11 and integration of cot u nothing but log of modulus sin u plus c equals to 1 upon 11 log modulus sin, what is u? U nothing but 11x plus 4 plus c is required solution. Now example 3, how to find out integration of sec of ax plus b with respect to x. Now integration of sec x, the basic formula for integration of sec x with respect to x equals to log of modulus sec x plus tan x plus c. Example, how to find out integration of sec ax with respect to x. Procedure step number 1, let ax equals to u. Derivative of ax with respect to x equals to du by dx. Derivative of ax is a equals to du by dx. Therefore dx equals to du upon a. Now I equals to integration of sec In place of ax, write down u, and in place of dx, write down du upon a. 1 upon a is taken common. Integration of sec u with respect to u, 1 upon a. Integration of sec u nothing but log of modulus sec u plus tan u plus c, that is equals to 1 upon a log modulus sec u. What is u? U equals to ax plus tan ax modulus close plus c. Therefore, integration of sec ax with respect to x equals to 1 upon a log modulus sec ax plus tan ax plus c. Next one, if it is ax plus b given, then how to find out integration of sec of ax plus b with respect to x? The procedure remaining same. Let ax plus b equals to u, then a equals to du by dx, then dx equals to du upon a. Therefore, I equals to integration of sec u du upon a, 1 upon a outside, integration of sec u with respect to u, therefore 1 upon a, and integration of sec u nothing but log of modulus sec u plus tan u modulus close plus c, 1 upon a log modulus, in place of u write down ax plus b plus tan of ax plus b modulus close plus c. Therefore, integration of sec ax plus b with respect to x equals to 1 upon a log modulus sec of ax plus b plus tan of ax plus b plus c. Here are the two examples. First is the evaluate integration of sec phi x with respect to x. Second example, evaluate integration of sec 10x plus 9 with respect to x. So let I equals to integration of sec phi x with respect to x. Let phi x equals to u implies dx equals to du upon 5. Then I equals to integration of sec u du upon 5, 1 upon 5 taken outside, integration of sec u with respect to u equals to 1 upon 5, integration of sec u nothing but log of modulus sec u plus tan u modulus close plus c. So 1 upon 5 log modulus sec u nothing but 5x. So sec 5x tan 5x modulus close plus c is nothing but integration of sec 5x with respect to x. Similarly, to evaluate integration of sec of 10x plus 9 with respect to x, put here 10x plus 9 equals to u, then 10 equals to du by dx. Therefore, dx equals to du upon 10. Therefore, I equals to integration of sec u du upon 10. 1 upon 10 is taken outside. Integration of sec u with respect to u equals to 1 upon 10 log modulus sec u plus tan u modulus close down plus c. So that is 1 upon 10 log of modulus sec u. What is u? 10x plus 9. To put back here. So 1 upon 10 log sec of 10x plus 9 plus tan of 10x plus 9 plus c. Therefore, integration of sec 10x plus 9 with respect to x equals to 1 upon 10 log of modulus sec of 10x plus 9 plus tan of 10x plus 9 plus c. Example 4. How to do integration of cosec of ax plus b with respect to x. The basic formula for integration of cosec x with respect to x equals to log of modulus cosec x minus cotx plus c. So there are the two situations. One is the integration of cosec ax with respect to x. Another one, integration of cosec of ax plus b with respect to x. In both the cases, the procedure remaining same. Here ax equals to u and here is ax plus b equals to u. Both are same, only here the b is extra. Now derivative of ax is a equals to du by dx, and here is the derivative of ax is a, derivative of b 0 equals to du by dx. Left side implies dx equals to du upon a, and right side the same thing, dx equals to du upon a, and therefore in left side integration of cosec u with respect to du by a equals to 1 upon a, common integration of cosec u with respect to u, that is equals to 1 upon a modulus of log cosec u minus cot u plus c. So 1 upon a log modulus, in place of u write down ax, so cosec ax minus cot ax modulus close plus c. This is the integration of cosec ax with respect to x. In RHS, integration of cosec of ax plus b with respect to x equals to integration of cosec u into du, that is with respect to du upon a, that is 1 upon a integration cosec of u with respect to u equals to 1 upon a log of modulus cosec u minus cot u modulus close down plus c. Putting back the value of u, so log cosec u, that is ax plus b minus cot of ax plus b modulus close down plus c. This is the integration of log of cosec of ax plus b with respect to x. Suppose we want to find out integration of cosec of tan x with respect to x. Then what you can do, let tan x equals to u, then derivative tan equals to du by dx, then dx equals to du upon 10. This is the step number 1. Then I equals to integration of cosec u du upon 10, 1 upon 10 is outside, integration of cosec u with respect to u 1 upon 10, cosec u integration nothing but log of modulus cosec u minus cot u plus c, so that is 1 upon 10. Putting back the value of u, cosec u nothing but tan x minus cot tan x plus c is required solution. Last example, integration of cosec of 3x plus 2 with respect to x. Step number 1, let 3x plus 2 equals to u, then 3 equals to du by dx, then dx equals to du by 3. I equals to integration of cosec u with respect to u upon 3, 1 upon 3 taken outside, integration of cosec u with respect to u, I equals to 1 upon 3 log of modulus cosec u minus cot u plus c. Putting back the value of u nothing but 3x plus 2 cot of 3x plus 2 modulus plus c. This is required integration of cosec of 3x plus 2 with respect to x.